To support ride-sharing apps such as Uber or Lyft, millions of drivers continuously send their latest location to the software servers. In a software system design interview for a ride-sharing service, interviewers often ask how the system can handle such high throughput. When we need to handle requests at high throughput, Redis, an open-source in-memory data store, is a popular design choice. In this video, we'll measure the throughput for Redis to increment counters and to insert longitude and latitude coordinates. For testing purpose, we'll run one or more Python clients and a Redis server on the same Mac laptop. I have uploaded the source code for the load tests to GitHub under the Redis speed repository. There are two folders under it. The scripts in the counter load test folder test the throughput for Redis to increment the counter. The scripts in the geo add load test folder test the throughput for Redis to insert geographical coordinates in terms of longitude and latitude. Let's start our tests to increment a counter. In step 1, we test how fast Python can increment a counter in memory without connecting to Redis. Based on the test, the Python script can increment a counter 15 million times a second. In step 2, we connect to Redis server and test how fast a single Python process can increment a Redis counter. Based on the test result, a single Python process with a single thread can increment a Redis counter 32,000 times a second. In step 3, we test the speed for Redis to increment a counter using a Python process with 5 parallel threads. Each thread increments a Redis counter 200,000 times, and together they increment the same Redis counter 1 million times. Based on the test result, a single Python process with 5 parallel threads can increment a Redis counter 34,000 times a second. Not much faster than a single thread. In step 4, we use 5 parallel Python processes to connect to the Redis server and test how fast they can increment the same Redis counter in parallel. Based on the test result, 5 parallel Python processes can increment a Redis counter 98,000 times per second, which is much faster than any of the tests we have performed so far. Now we know that with our simple setup, we can increment a Redis counter 98,000 times. This is really fast, but is it because changing a single variable takes very little memory compared to other operations? Next, let's test how fast we can insert 1 million random geography coordinates into Redis. Let's use the Python scripts in geoadd load test to test longitude and latitude related operations. In our first step, we write a Python generator function that yields 1 million longitude and latitude pairs one at a time without connecting to Redis. This is to make sure that Python does not create too much overhead for our load tests. Based on the test, Python generator function can generate about 200,000 longitude and latitude pairs in 1 second. This is likely too much overhead for our load tests, considering we can increment a Redis counter almost 100,000 times a second. To reduce the overhead for our Python code to generate geography coordinates, let's change our test to generate 1 million random coordinates ahead of time and only measure the speed we can iterate through the pre-generated array. Based on our test, we can iterate through about 3 million pre-generated geography coordinates per second using Python code. The overhead is low enough for us to continue our load test against Redis. In step 2 of our geography test, we use a single Python process with a single thread to insert 1 million random geography coordinates into the same Redis set and see how fast Redis can take in these coordinates. Based on our test, a single Python process with a single thread can insert 28,000 coordinates into Redis every second. In step 3, we use 5 parallel threads to insert 1 million longitude and latitude pairs into the same Redis set. Based on our test result, we can insert about 28,000 coordinates into a Redis set using 5 parallel threads, almost the same speed as the result when using a single thread. In our last step, we try to insert 1 million longitude and latitude pairs into Redis using 5 parallel Python processes. The result with 5 processes is much better than 5 threads. We're able to issue 76,000 requests per second to insert coordinates into the same Redis set, and we inserted 1 million records. Based on these tests, Redis can handle 98,000 requests per second to increment a counter and handle 77,000 requests per second to insert geography coordinates into a set. Inserting geography coordinates is slower than incrementing counter, but not much slower when we have 1 million coordinates in the set.